picking up where we left off yesterday. Okay, we had finished in your class up through 2A on the front. Yeah. I think I, at the very end, hurriedly put down the range. So we'll talk about that again in this one. So the questions are, what are the vertex, axis of symmetry, max min value, and range? So I don't know what you guys remember from yesterday, but where do we need to start? Okay, ABC. And what are we going to be trying to find first with those ABCs? Okay. Axis of symmetry is actually the first thing we find. Okay, so remember, this is given in standard form. So negative 3x squared minus 4x plus 6, remember, is in ax squared plus bx plus c. What are my ABCs in this problem? A is negative 3, B is negative 4, C is 6. Okay. Axis of symmetry formula. What was it? That's right. Okay, so axis of symmetry formula, x equals negative b over 2a. Negative b, what's that mean? That means it's going to be positive 4 over 2 times a, which is negative 3. 4 over negative 6. What do you guys know about 4 over negative 6? Okay. Negative 2/3. So, axis of symmetry is the equation x equals negative 2/3. Remember, that's the equation of the axis of symmetry. That is also my H, X, first half of the vertex. Now, okay, one of the ones we did yesterday, we had a fraction, yes? But that fraction involved a half. So we could easily turn it to a decimal. This one, negative 2/3. If you turn it to a decimal, it's 0.666666666, so on and so forth. Now, here's the deal. If you just change this to a decimal and say, okay, I'm just going to use 0.6, or I'm just going to use 0.66, or I'm just going to use 0.7 or 0.67, you're not going to have a 100% accurate answer. So this is a situation where we need to stay with the fraction, whether we like it or not. Now, depending on how well you know how to use your calculators can actually deal with fractions. And I can show you some tips there. Okay, vertex. What do I already know about the vertex? Okay, vertex is negative 2/3. How do we find, by the way, vertex is the next thing we find. How do I find the second half of the vertex? How are we going to find the second half of the vertex? Plug it in. Okay, take your h value, your x value, plug it in to the original y equals equation. So, y equals negative 3 times negative 2/3 squared minus 4 times negative 2/3 plus 6. Okay. Start with your exponents. Negative 2/3 squared. Okay, what's it mean to square something? Times it by itself, right? So look at the top. My top is 2. What is 2 squared? 4. My denominator is 3. What is 3 squared? 9. And what happens when you square a negative? A negative times a negative is a positive. So that piece right there becomes 4/9. Now, the other part we're doing is negative 3 times 4/9. How do I make negative 3 a fraction? Put it over 1, and then multiply. Or, I say multiply, what's the other option? Cross cancel? Not cross multiply, cross cancel. Personally, what I would do, what do you know about 3 and 9? They reduce. They both divide by 3. 3 divided by 3 is a 1. 9 divided by 3 is a 3. Or you can think of this still as negative 1. So now when you multiply across, negative 1 times 4 over 1 times 3 makes this part negative 4/3. Okay. The next part, we have a minus 4 times a negative 2/3. How do I make the 4 a fraction so I can multiply? Put it over 1. Now this time my 4 and 3 do not cross cancel, so just multiply across. Negative 4 times negative 2 plus 8. 1 times 3, 3. So now we're at 8 over 3. Now, the last part is a plus 6. Before I write down my plus 6, what do you notice about the other two pieces?
Oh, the plus 3, you can cancel.
Can't cancel, but they do both have denominators of 3. The key is, in order to be able to add and subtract, if we all have a common denominator, it's going to be easier. So these two are set to add with a common denominator of 3. My question is, can you take that 6 and make it have a denominator of 3 so I'll be set up to add? You can. Okay, so think of this. Okay, so 6 is a fraction, is 6 over 1. How does this 1 turn into a 3? You times it by 3. If you times your denominator by 3, you got to times your numerator by 3. 6 times 3 is 18/3. I set this problem up to be easy from here on out. Negative 4/3 plus 8/3 plus 18/3. They all have a denominator of 3. So what's that mean? We keep the denominator of 3 and do the math. Negative 4 plus 8 is 4. 4 plus 18? 22. Hey, I'll take it. He got us there, didn't he?
Amen.
You know some of you are doing this in your head, thinking exactly that in your head, so.
If you put this in a calculator, it gives you 7.333.
Okay, so do you know on your calculator how to change from a fraction to a decimal? In other words, if I have, whoops, not what I want to do. If I have 7.333333 showing on my screen, first of all, 7.3 repeating is equivalent. I don't know if Math Excel would accept it. Just saying. I agree, probably not. First of all, it is helpful to know that 0.3 repeating, it's helpful just to know what that is as a fraction. However, if you don't, on my calculator, any scientific calculator has this somewhere. And graphing calculators have this too. On my calculator, right there above the PRB button, it has FD and a double arrow between it. That is what allows me to change back and forth from a fraction to a decimal, or a decimal to a fraction. Whoops. Okay, I hit a button. So, I have 7.333 showing on my screen. If I hit second, and then the FD button, it's going to take a fraction answer to a decimal or a decimal answer to a fraction. My calculator now just told me 7 1/3. So it gave me a mixed number. I also have the option on most scientific calculators of going between, this is a mixed number. Your calculator will tell you improper. For me, that is using the ABC to DE button, because that will take me back and forth. So if I do second and that button, it will take me from 7 1/3 to 22/3. If I hit it again, it will take me back to 7 1/3. If I want to go back to a decimal, I can hit the FD button, and it will take me back to a decimal.
Mine's broken. Mine's broken.
Yes.
Where's it on this?
That's a graphing calculator, so you want to go in the math menu. So you have a math button at the left, which has lists everything. Right here, number 1. So if you have a decimal, you want to go to a fraction. You hit that after it.
I want to make it a fraction here.
And if you a decimal, select. Okay. So if I had 7.3, yes. And I want to turn that to a fraction. If I hit math, I want to turn it to a fraction. So I hit enter, saying it's taking your last answer to a fraction. That would show me 2/3. My last answer is a fraction. If I want to be a decimal, right there, that, and it's going to take my last answer to a decimal. I told you it's there. It's just a little different, right? And guys, I'm always more than willing to help you find what you need to find on the calculator you're using. It's there somewhere. It's just a matter of finding it. Okay. Now, I could take 22/3, or notice the other option we had. The calculator did tell us 7 1/3. Okay, so we had a big break in there. What is that 22/3 or 7 1/3? It's the Y value, other half of the vertex. Very good. I don't care which way you write it. If I write 7 1/3 here, that's fine. That is my vertex. Also keep in mind, it's the second half of my vertex. It's my K value. Okay. So number 1, axis of symmetry. Use that formula. Number 2, vertex. Use that axis of symmetry. Plug it in. Three is max-min value. So, in order to know if there's a max or a min, we have to know something about this parabola. What do we have to know? Up or down? Okay. How do I know my parabola is upside down? Okay. Good. So because my A is negative, that tells me my parabola is upside down. An upside down parabola has a maximum vertex. So, the vertex is a maximum. What is the maximum value on that vertex? How high does my vertex go? What? No. What'd you say? 22/3? Where do you find that max or min value, guys? The K, the second half of your vertex. Because my vertex says I'm going to go left 2/3, and my vertex says I'm going to go up 7 1/3. That Y value is your max value. So I don't care if you say 22 thirds, 7 1/3, whatever. But that will always be your max or min value every time. Okay, fourth and final thing to find is the range. Okay, my parabola was what? Upside down. The max was at 22 thirds, 7 1/3. Where is the rest of my parabola from that? If that's the maximum point, the rest of my parabola is down. So what do I say for my range? Yep. Range. First of all, always use y for range. Since it's a max, that is the highest point, so the rest of it is below that. So you can say y less than or equal to 7 1/3, y less than or equal to 22 thirds, y less than or equal to 7.3 repeating. I'd accept any of those. MathXL won't. MathXL, I would say they want 22 thirds. Probably should have done that now that I think about it. But okay, guys. You got all the pieces there?
The domain's all real numbers.
Domain is all real numbers. I agree. You're just hoping you get an easy point out of that today, right? Okay. Moving along then. Let's move into example 3, and let's practice graphing. Okay. The graphing we did back in lesson 4.1. The graph we did back in lesson 4.1 was based on just your regular parabola, the 0, 0, 1, 1, 2, 4, and we were moving it left, right, up, down. That was the basic graphing we did there. Okay? The graphing in this section, we don't necessarily have, this is standard form, not vertex form. So I can't tell by looking which way my vertex is going to go. Gentlemen, focus up here, please. So, in order to graph this, any guesses or thoughts on what we're going to need to find? Vertex. Okay, you can't graph a parabola without knowing the vertex. Impossible. So we have to know the vertex. Before we can find the vertex, what do I have to find before I can find the vertex? Axis of symmetry. Okay, so same process really we've done the last 4 problems. We're going to have to find the axis and the vertex. It's just our end result. This time is we're going to be graphing. So, okay. What do you know about this form it's in? I think she said it. ABC? What's A? 1, it's in front of x squared. What's B? 2, it's in front of x. What's C? 3, it's the constant at the end. So A, B, C. Know your ABCs for math. It's important. Okay. Not a new question. How do I find that axis of symmetry? Negative b over 2a. X equals negative b over 2a. So negative of, what's my b value? 2. So negative 2 over 2 times a, which is 1. Negative 2 over positive 2. And negative 2 over positive 2 reduces to negative 1. What is my axis of symmetry? X equals negative 1.
First half of your vertex.
First half of your vertex. Excellent. Okay, so that takes you right into the next part. Once you find your axis, you need your vertex. I already know that my vertex is negative 1, comma, something. How do I find the something? Plug -1 into the original equation. So, -1 squared plus 2 times -1 plus 3. -1 squared. -1 times -1 is +1. 2 times -1 minus 2 plus 3. 1 minus 2. So -1 plus 3. 2. What do you know about that 2? It's the second half of that vertex. You are going to need room for a graph. So notice I'm keeping all my stuff to the left. Now, besides the axis of symmetry in the vertex, so we now know where we're going to draw that invisible dotted vertical line for axis of symmetry. We now know where our vertex is going to be on there. In order to draw a good parabola, you need at minimum one more point. And I'll be happy with one more point, but we have to have one more point. Now, that was the guess. Okay, so now, you have a nice, easy one more point on a problem like this. Not 0, 0. Okay, so right here, my axis of symmetry is -1, 2. So what that means is my parabola is no longer centered on that y-axis. But you can find a y-intercept by plugging 0 in for x. If I plug 0 in for x here, what am I going to get? 0 plus 0 plus 3. Okay, so here's what I'm trying to tell you guys. Or, your C value is always your y-intercept. Because you plug 0 in for x, and you will always get that C value. So here's what I'm going to tell you. Y-intercept is 3, because C is 3. Or in other words, it's the ordered pair 0, 3. That's the easy way to find another point. Besides that, after having that other point, what do you know about a parabola? The left and right are the same. It's symmetric, yes? So if 0, 3 is on the right side of the axis of symmetry, then you can reflect to the left side, or whichever way you need to go. So the side comment I'm going to write here is just reflect across axis of symmetry. Okay, that's how we will finish this problem off. Okay, so we ready to graph? Hopefully you left some room somewhere there on the right. As you draw that graph, think about what room you need. Okay. You can kind of see it. Okay. So, I'm going to label. I know I have to be able to go at least left 1. I know I'm going to have to be able to go at least up 3. Be a little bit more than that. So, I think if I label 3 in all directions, honestly, you don't even really need to label down on this one, but okay, you ready? Start by drawing in your axis of symmetry. My axis of symmetry is x equals -1. What's that mean I draw? vertical dotted line where x is negative 1. So that means I need to go left 1 and put in a vertical dotted line. What should be on your axis of symmetry? Your vertex. That's the whole idea here. What's my vertex? Negative 1, 2. So what that means, technically from the origin, we go left 1, up 2. Or in other words, on your axis of symmetry, which is negative 1, you're going to go up 2. So that is a vertex of negative 1, 2. What's the other point I know? 0, 3, my y-intercept. So I know my parabola will cross through the y-axis at 3, which is right there. Now, how I always ask this, where is that 0, 3 in relation to my axis of symmetry? It is 1 to the right. Does that make sense? So this is 1 to the right of the axis of symmetry. So I need a corresponding point that is 1 left. So it's going to end up at negative 2, 3. The point on your axis of symmetry needs to be your vertex. Is that set up to be my vertex?
Yes.
Yes. Which way is my parabola set to open? Up. Should it open up? Yes, because A was positive. Should look something like that.
Oh, shoot. Finish notes for the week.
Should we keep one of them, or we can do at least one of them?
So I was just debating.
It's based on
Okay. Based on the other fact, my other two classes are a problem behind, so it's going to take them a little bit of time to catch up today. Based on the fact that we are missing half of our class today, I think I will, and I don't know that we'd even get through the whole next problem anyways. I think we'd get caught in the middle. So we're going to stop there, and we'll pick up here tomorrow. Tomorrow, I will plan to do example B here, and I will probably plan to do one of the word problems. They're essentially the same, if I recall, so I'll probably plan to do one and show you how to do one of them. Anything else past that tomorrow will be work time. Now, you are still allowed to go ahead and get started on homework, yes? Okay, so as there's pieces, really you should be able to do most of the homework now. So feel free to get started on homework as you want. Homework will not be due till Friday, though. And I believe that's what it should say in Math Excel.